In this video lesson, we're going to show you how to multiply when numbers are in scientific notation. Here's an example problem. We have 1.5 times 10 to the 6th power, and that's going to be multiplied with 4 times 10 to the 4th power. Two large numbers multiplied by each other. If we review the objectives for today, the objectives explain to us that there are two different methods that we can use to multiply or divide numbers that are in scientific notation, kind of like when we added and subtracted. Option 1, it's a two-step process where we switch them to regular numbers, decimal notation, and then we multiply or divide using the standard algorithm. Option 2, which we'll show you as well, is we're going to multiply or divide the coefficients together, then separately we multiply or divide the powers of 10. If we were going to use method number 1, the first job is to switch both of these scientific notation numbers into regular notations. So 1.5 times 10 to the 6th, if we switch that over to a regular number, is 1.5 million. We see the decimals moved 6 places. 4 times 10 to the 4th, 4 times 4 copies of 10 would make 40,000. Now that both of these numbers are in regular notation, we could go ahead and multiply using the standard algorithm. Standard algorithm is a fancy way to say this is how you multiplied back in 4th and 5th grade. Here, 0 is not going to multiply with anything. This 0 makes nothing. Same with this 0. So all we really have is the 4, but we see there were 4 places before that. So if we remember from the standard algorithm, we already need 4 zeros there for these 4 places. 4 times these 3 zeros is going to make 3 more zeros. 4 times 2 more zeros, 2 more zeros. Now, 4 times 5 is going to make 20. That's a 0 carrying the 2. 4 times 1 carrying the 2 is a 6. So we see the standard algorithm is not very fun when we have to multiply two large numbers together because it gives us all these zeros. But if I counted those zeros correctly, there's my final answer, 60 billion. If we wrote that in scientific notation, 6 times 10, and how many places do we move? 3, 6, 9, 10 places. So that number is 6 times 10 to the 10th. As we see, method 1 here, even though it was good for adding and subtracting, can kind of be difficult for multiplying scientific notation numbers. Method 2 instead says us to use the coefficients and the powers of 10 separately. We're going to times the coefficients together, the powers of 10 together. So in this case, we're going to go ahead and rewrite this expression instead to say 1.5 times 4, we're going to put the two coefficients together first, and 10 to the 6th times 10 to the 4th is going to be put at the end. I know that 4 times 1 is 4, and half of 4 is 2, so if I put 4 plus 2 together, I know that 1.5 times 4 makes 6. That's still going to be multiplied with 10 to the power of 6 times 10 to the power of 4. We know from our rule with exponents, if we have the same base times together, we can just add those exponents up. 6 copies of 10 times 4 more copies of 10 actually is just going to give us 10 total copies of 10. We see for method 1 and method 2 we get to the same answer. You'll decide which method's best for you, but I think you can see method 2 kind of makes it a bit easier because we don't have to worry about counting all these zeros. They're just contained in the powers of 10.